Hi, I'm Nicole Belanda, the Customer Advocacy Program Manager from Rockwell Automation, and we're here to talk about results achieved. I'm joined by Bryce from Hexcel and Chase from EOSYS to talk about some great results that they've achieved. Hi, guys.
Hi. Hello.
I'll have you introduce yourselves. Let's start with you.
Yeah, so my name is Bryce Wengren. I've been with Hexcel Corporation for about 9.5 years now. About 13 years in the industry. I've been in mining and minerals as well as composites.
Nice.
I'm Chase Davis. I'm the Director of Technology for EOSYS and been with the company for 20 years.
Can you talk a little bit about the company?
We were founded in 1991 and we have core automation business and digital transformation business.
Great. And tell us a little bit about Hexcel.
Yeah, Hexcel's a composite leader in the world right now. We make everything from engineered core to carbon fiber to pre-preg fabrics, woven fabrics. Basically, we have a saying, if it flies, we're on it. And we have facilities in the U.S. and throughout the world.
Tell us a little bit about the project that you two worked on together.
We were having failures in our equipment on the encoders on our motors. Each one of these downtimes would cause roughly $70,000 instant hit of loss and $7,000 an hour. We were having a lot of these issues, so our plant management came to me and wanted to come up with a solution. At that point, I had talked with our Decatur, Alabama facility who had engaged with EOSYS, and they introduced us to us.
In the Decatur, Alabama facility, they use permanent magnet motors on all of their lines, and they don't have encoders, and they are able to achieve the speed regulation tolerance that they need. So that was really our first approach, was let's make small changes. Let's introduce a permanent magnet motor. We'll still put the encoders on there so you have peace of mind, but we started with that approach, trying to make incremental changes over time from project to project to continue getting better and achieve the end result, which was to reduce their unplanned downtime.
So we wanted to make the adjustment on one of our smaller lines. So in our Salt Lake City facility, we have 14 manufacturing lines ranging in age and ranging in technology levels. And this particular line was our very first line that was put into service in 1976. So it had some pretty old technology in it. So we converted the line to AC drives. We implemented permanent magnet motors because we only had 5 that we needed to change out. And it went really well.
So then we took the success from that line, we went to a much larger line that had 30 motors on it. So we were going to go permanent magnet motors and continue with that success. But we ran into issues there with it being a larger line and the distances from the drive to the motor. We were having overcurrent issues. We also received motors that were 120 hertz base speed, which is not normal.
So we decided to go with an induction open loop, which was a theory we were thinking about. We got the line up and running and everything was going good. With Hexcel, we are heavily qualified material. So our customers, Boeing, Lockheed, Airbus, they have specific specifications that we have to hit. And if we manipulate any of those that could adjust the mechanical properties of our product, we have to tend to shy against those changes. With encoder control, you're getting very, very tight resolution control. And the open loop control obviously gives you a little less, but what we came to find out was that we really needed plus or minus 2% speed control, where we were still achieving 0.05% control. So I use the analogy, if you were asking us to chuck a baseball into a baseball stadium and hit the field, well, I'm still hitting the pitcher's mound every time. And that helps alleviate a little bit of the tension, and we were able to move forward with our phase 3 approach.
So next we went to the next line, which was actually 2 lines we were going to do at the same time. And we didn't buy permanent magnet motors because we had proved we could do this with induction motors. We were going to use sensorless vector control, and we put the encoders on there for operations peace of mind, where we can say, okay, we have the encoders on there. We enabled a feature in the drive called TAC switchover, which is supposed to detect a failure of the encoder and then switch over to open loop instead of shutting down the line. So we had a little bit of success there. Bryce can probably tell about how the issues we had with that TAC switchover feature wasn't exactly as reliable as we wanted it to be.
When we would trigger the switchover, the parameter transition wasn't as smooth as we expected either. So we would get a little bit more variability in the speed, which it wasn't necessarily causing problems on a line, but it was causing problems with operability. So we needed to look for another solution, and that's where we moved to our phase 4, 4.0, where we looked at a line that was full induction motors. And we went with the approach that we were going to just do a open loop control with the induction motor with the encoder feedback, giving alternate velocity feedback to give a peace of mind to the operators and to the process.
Yeah, so we weren't using the encoder for control, we were just displaying it back to the operators so that they can see, I told it to run this speed and it's actually running this speed. And so that was really the best of, what we were trying to get to. And then Bryce was able to go back to pretty much all the other lines and say, this is the model that we're going to use going forward.
Yeah, we ended up making a corporate standard on this model, and we rolled it out to the rest of the lines remaining at our Salt Lake City facility. And then we rolled it out to our Roussillon, France facility. And eventually it'll roll out to our Spain facility as well when they're able to upgrade.
We were kind of talking about the next lines that he needed to do, and we said, hey, let's use the TS drive because it has the advanced features of adaptive tuning, load observer, and some other things that he was wanting to do with Guardian AI and analytics on it. We helped with the install, and then we left, right? And then he was the one that was really doing most of the work on there. So
yeah, what we wanted to do was we wanted to leverage the new tech. We wanted to, look forward. That's kind of my role in the company now, is to look forward at the new technology and trying to implement it, or get us prepared to implement the architecture. And with the TS drive, we wanted to leverage the analytic capability because with our downtime being so costly, we wanted to have predictive maintenance. We wanted to have process anomaly detection. We wanted to be able to leverage the data that was coming out of the drive to mechanically correlate problems with the system to defects or anomalies in our product. And we were hoping these drives were going to be able to help us, and that's to be seen still. We are on deck for some projects to implement Guardian AI, data mosaics and optics to utilize all this data to give us the results we were looking for.
That's exciting. Okay, I'll have to find you in a few months and see how things are going. What results have you seen so far to date, though?
Success of the project is we took our encoder failures from a lot to zero. In doing so, we also increased the reliability of our communication protocols by switching our drives from ControlNet to Ethernet. And then we helped achieve our unplanned maintenance downtime from 2% in 2017 to 0.4% in 2019, right before COVID.
I can tell just from hearing the two of you talk that this was a partnership. It wasn't, fully led by either party, and it sounds like what you were able to build as a result was even greater than you would have been able to build solo. So very cool to hear your story. Thank you both for coming today.